Hello and welcome to another video. Today we will be learning about vector operations. The first operation that we're going to be learning about is vector addition. So as the name says, we're going to be adding two vectors together, creating a new vector. So let's look at this example. We have vector u, which is equal to the vector 2, -6. And then we have vector v, which is -4, 6. We are trying to find the addition of both of those vectors, so we're finding u plus v. Doing this is very simple. All you have to do is add the first component plus the first component. So the first component of u is going to be 2. The first component of v is going to be -4. So I just wrote 2 plus -4 for my first component, and then for my second one, I'm going to have -6 plus 6, my first component, and my second one. Again, we're adding them together. -4 plus 2 is going to be -2, and then -6 plus 6 is going to be 0, giving us our final answer. Pretty easy, very basic information. Looking at another example, we have u, which is -6, 7, and then we have v, which is -4, 3. We're trying to find the addition of the vector u plus v. I'm going to do the same thing, add the first component, which is -6, plus the first component, which is -4. And then I'm going to add the second component, which is 7, plus 3. That will give us the answer -10, 10. And we are done. When we do subtraction, we actually have two different ways to do it. We can change it into an addition problem, or we can keep it as a subtraction. So I'm going to do one of each, just so you can decide which one you like better. So I'm going to find what u minus v is. So first I'm going to rewrite u, which is -6, 7, minus v, which is -4, 3. Think of this as a distributive property, distributing the negative to both of the components. So that will be -6, 7, and then change it into a plus sign. So negative times -4 will give me +4, and then negative times 3 will give me -3. Some people like to do this, that way they don't forget to distribute the negative to both. After you do that, very simple addition problem, component 1 plus component 1, and then component 2 plus component 2. -6 plus 4 will give me -2, and then 7 minus 3 will give me 4. And then that will be my final answer. If you want to do a subtraction, you can do that as well. Just make sure to subtract both of them. So I'm going to rewrite the component of the first one, which is 5, minus -2. And then the second component, which is -3, minus -6. Again, we are subtracting both of them. So that's why you see the subtraction sign in both of the parts. This becomes plus, plus. Same as this, we have two negatives next to each other. So that will become 7, 3. And that will be our final answer. Going to the last operation, which is multiplication, also called a scalar. So basically all you're doing is multiplying your vector times a number. Basically what this will do, it will not change the direction of the vector, but it will make it either longer or shorter depending on the number. In this case, since we have 3 times u, the vector will be 3 times as large as the original. Again, think of it as the distributive property. So I'm going to put my 3 times my vector u, which is -6, 7, and then distribute the 3 to both of the components. So 3 times -6 will give me -18. 7 times 3 will give me 21, giving me my final answer. Again, pretty easy. Just remember to distribute the scalar to both the a and the b, or your first and second component. If you have a negative, it will be very similar. So -2 is your scalar, and then u will be -6, 7. Again, distribute the -2 to both of the components, so that will be negative times negative, which will give me positive 12, comma 7 times -2, which will give me negative 14, giving me my final answer. Don't forget you can combine them, like 2u minus 3v, and then you will just follow the process individually. Thank you for watching, and hopefully you learned something. See you next time.